Hello, my name is Alexander Garcia, and today I'll be teaching you 5 different methods of solving quadratic equations or functions. This is an important skill that will follow you throughout your entire math career. I think you'll be quite interested. So, moving on, we're going to be finding x now. Finding x is very similar to finding y, obviously, but instead we're going to be using y to draw wherever we have a y value, we are going to be drawing a horizontal line. Why horizontal line? That's very simple. That's because x represents the horizontal axis. So in order to find x, that we have to draw a horizontal line. As you can see, I wrote the equation of the parabola in vertex form. I did this simply because vertex is by far the easiest to transfer onto graphs. You could really solve using vertex standard intercept. It's just easiest to use vertex. So let's get into this. When f of x is equal to 3, or otherwise when y is equal to 3, what would x be? Well, let's see. Let's go to where 3 is on our graph, which would be around here. Draw a vertical line. Oh, that's very easy. Horizontal line, apologies. We're going to have the value of 5. So that means when f of x is equal to 3, or when y is equal to 3, x will be equal to 5. Let's move on to this one. This one is more interesting. When f of x is equal to 5, what would x be? So let's go to where 5 is, which is right here. Draw our vertical line. What? We have two different equations. Two different answers. What do we do? Well, it's very simple. You write down both. Or you have two solutions, basically. You have both 3 and you have 7. What would you do? Well, you just write them both down. You could write it as in parentheses for both of them, 7, 0 and 3, 0. That is the easiest way to answer that. Let's go down here to f of x is equal to minus 7. We draw our line. Oh my goodness, it misses it entirely. What does this mean? This means that when f of x is equal to minus 7, there's no parabola. There's nothing to go off of, meaning that there are no solutions, no possible x values. Next up, we're going to be learning the square root method. The square root method, while harder than the graphing method, is still very key and not that much more difficult than any other method. The main reason to use the square root method is when you're missing the linear term. The linear term, you have the quadratic term, the constant term, or a of x squared and c squared, but no b of x. That's missing. So what exactly is it? Well, it's basically taking the square root of squaring two different values to produce the same answer. So we must take the square root of value, and we must remember that the answer can all be negative and positive when we're doing it. So let's get into practice. Let's say we have the equation f of x equals x squared minus 9. The easiest way to do this is to make x, or f of x, equal to 0, because every equation is infinitely easier when you have a 0 as your y, because you have nothing altering what you're going to do next. So you're going to add 9 to both sides. Boom. You go over here. X squared is equal to 9. So after you do that, you have to find the square root of both. And remember, the answer can be positive and negative. So for 9, you add a plus or minus sign, and you square root it. You square root both. When you square root x squared, you simply just get x. When you square root 9, you simply get 3. So x is equal to plus or minus 3. But let's say 0 doesn't automatically equal 9. What do we do? Well, it's not much harder, honestly. Let's say f of x equals x squared minus 4. And let's say f of x is equal to 12. So we put 12 there. And we honestly just continue on as we usually do. So plus 4 to both sides. That would make it 16 equals x squared. Then, after we do that, we simply square both sides as we did last time, remembering that it can either be plus negative or positive. And then we end up with x equals plus or minus 4. Next up, we have factoring. Factoring may seem very complex at first, but in actuality, it is quite simple. The first thing you gotta remember about factoring is that it will always equal to 0, and x and a y will always be equal to 0. What does that mean? It basically means that an x in an equation will be 0 times y will equal to 0. Well, the y is 0, meaning x times 0 is equal to 0. This seems pretty easy, right? That's just common sense. Well, using that, we are able to advance it into factoring. First off, let's look. 7x equals 0. That means x has to be equal to 0. Something a little harder. 4 in parentheses x minus 9. Well, what we have to do is that x obviously has to equal 9. Why? That's because we go over here. 9 minus 9 is equal to 0. 0 times 4 is equal to 0. Simple. What about down here? Down here, you're going to have two different things. Why? Because the same answer wouldn't work in both areas. So on this part, you'd have minus 8 because 8 plus minus 8 is equal to 0. On this side, it'd be 3 because 3 minus 3 is 0. Again, these are very easy principles, but using them, we're able to solve factoring equations very easily. Let's move on to this box right here. We have the equation 9x squared plus 3x. This, you can't really do anything too complex with it. The greatest thing you can do is find the greatest common factor. What is it? 3x. So 3x in parentheses 3x plus 3. What do we do next? Well, it's quite simple because these in parentheses and this is over here, and you have two different x values. You separate it, making two different equations. 3x equals 0, and then 3x plus 3 equals 0. 3x equals 0. What do? Well, you just make the x equal 0. So x equals 0. 3 times 0 is 0. This part is a bit more complex. You got to do a bit of more complex math. You got to go plus 3, put that over here. 3 divided by 3. 3 divided by negative 3 equals minus 1. That means x equals minus 1. So your two answers are x equals 0 and then x equals minus 1. Next up, we have a bit more complex. If you remember square roots, that's basically what we're going to be doing here. We have the equation 16x squared minus 81. So first you got to add 81 to this side. Boom. 16x squared equals 81. You square root both. You get 4x equals plus or minus 9. After you do that, it is pretty simple because plus or minus, you basically turn it into two different equations. One where it's plus 9, one where it's minus 9. You go down here. You can solve it using the same principle as used here. So basically, plus 9 divided by 4, 9 over 4 equals x. And then over here would be the same, but flipped. So x equals minus 9 over 4. Use the same arithmetic for both. I just simplified on this end, so I'm just like not repeating myself. Next up, we have this. You have three different answers. Three different numbers. You have a of x, b of x, and c of x. Yeah, sorry. A of x, b of x, and c of x. What do you do here? Well, it's actually not as hard as you think. You just gotta remember this principle. Whatever two numbers can multiply into this and add into this. What does that mean? What that basically means, you need two numbers that multiply into C and then add into B. 7x plus 12. What equals 7x and 12. What two numbers can multiply into 12 and add into 7? 4 and 3. So x plus 4 and then x plus 3. And then what do? Well, how do you find 0? Well, minus 3 plus 3 is equal to 0. So that's one answer. And then x plus 4, that means minus 4. So minus 4 plus 4 equals 0. Pretty easy stuff. And so moving on from that, you got this equation right here. X squared plus 14x equals 40. Minus 40. That can be a little harder because you have something in the y. Well, you simply just have to move that over to make y equals 0. So you just add 40 to the side. You use the same principles here. So what two numbers multiply into that and add into that? 4 and 10. And then you go down here. What numbers go x plus 10, make x plus 10 equals 0? Minus 10. And then what number makes x plus 4 equal 0? Minus 4. Now to end this off, to end off this math, I have one last more complex equation to go into. (4x squared plus 8x plus minus 8x. Sorry, I can't read my own handwriting. Plus 3x minus 12. What could you possibly do here? Well, notice you have multiple x values, okay, and different one of these. This is not simple at all. The best way to do this is to separate this into two different equations. Then after you separate it into two different equations, the best thing you can do is find the greatest common factor for each. So you go here, what's the greatest common factor? 4x. What's the greatest common factor here? 3. Then after you do that, as you can see, x minus 4, that's the same thing. So you can simply keep that, and then you can have 4x plus 3. Pretty nice, right? After you do that, notice how similar it is to problems we've done before. So then we can do basic arithmetic. X minus 4, you can go here. What minus 4 equals 0? Regular 4. So x is equal to 4. And then here, 4x plus 3. I wonder. You got a minus 3. Put that over here. And then you got minus 3/4 is equal to x. That's factoring at its most basic level. Again, it is not as hard as it seems. Simply knowing these basic principles can help you further improve your factoring. Now we have completing the square method. This method is best used when factoring doesn't work. What do I mean by this? Let me explain. Look at this equation here. X squared plus 8x plus 10. Isn't that weird? 8x and 10. No two numbers can add into 8 and also multiply into 10. That means this equation basically is unsolvable, right? I mean, it would be solvable if we could just turn it into vertex form. If we could turn that into vertex form, we could basically just solve it. That is the whole point of completing the square. Let me explain exactly how this works. Look here, x minus 9 squared. Let's write that out in standard form. X squared minus 9x plus 81. Okay? Now combine like terms. X squared plus 81x minus 18x plus 81. Hold up. Do you notice that? Minus 9x and minus 9x. Those two numbers multiply into 81. But they also add into minus 18. What does that mean? Well, if we look here, if you divide the b of x in half, and then you square it, you can find the c. This is a key in using the complete square method. And as you can see, x minus 9, that's just the answers. So here now, x squared plus 7x plus what? So to find c, we got to divide b of x in half, which would be 7 over 2 squared. That would, what would that be? That would be 49 over 4. Not too hard, okay? But notice that this number can be used, boom, boom. We can use that to write it into vertex form. Oh my goodness, that ties into that. That's not all. Let's apply this. Look here, x squared plus 6x plus 12. Notice again, these two numbers don't add and multiply cleanly. Well, let's divide 6x. If we divide it in half, that's 3, and then we get 3 squared. So then, you have 3 squared here. So let's do x squared plus 6x plus 3 squared plus 12. That doesn't exactly work. That's because we also have to subtract 3 squared. Why? Because we are adding into this number, we also have to subtract it. So if we do that, okay, go here, we'll subtract it from minus 12. Notice that so now the equation becomes x squared plus 6x plus 9 plus 12 minus 9. Do you notice that x squared plus 6x plus 9, that forms a perfect square? So what we can do, we can separate these two numbers basically, or these two parts of the equation. We can turn this part of the equation into vertex form. It's pretty nice, right? And then after we do that, we simply just have to finish the equation or finish the solution by subtracting 9 from 12, making it x plus 3 squared plus 3. And now we can use that to find both x terms. It's pretty nice, right? But that only really works if it's f of x. What if it equals 0? These two things are different. When it is equal to 0, it becomes a different equation altogether. How do we do this one? Well, that's simple. We simply just have to add 4 to this side. Subtract 4. Apologies. We subtract 4, and then we have a missing c on this side. Then we simply do what we did over here. Divide it in half, square it, then put that over here. We don't have to subtract it on this side because these are two different equations, basically, separated by the equal sign. So we can do 4 plus 4 squared, which is 16, 4 plus 16. And on this side, x squared plus 8x plus 16. Then after we do all that, we can form a perfect square, meaning x plus 4 squared equals 12. Equals 12. Then we go 12. Then we square root both sides, getting this plus or minus square root of 12 equals 4x plus 4. And then we simply subtract 4 from both sides, so minus 4, giving us the solution of x equals minus 4 plus or minus the square root of 12. This is essentially how the square root method works. And finally, we have the quadratic formula method. This method is guaranteed to work every single time. However, it is known to be the slowest method out of them all. Let me show you. First thing you need, the quadratic formula. Quadratic formula is minus b plus or minus the square root of b squared minus 4ac all over 2a. This is the quadratic formula. It is very key in using the quadratic formula. Who could have guessed? However, writing all this down and solving all of this can be very time consuming. So it is often better to use any of the other methods in this video, but this is guaranteed to work every single time. Let's try an example. We have the equation 8x squared plus 5x minus 3. Let's plug in the numbers. So we have minus 2 plus or minus the square root of 2 squared minus 4 times 8 times minus 3, all over 2 times 8. So we add all that up. We have minus 2 plus or minus the square root of 100 all over 16. Then we simplify that. The square root of 100 is 10. So we have minus 2 plus or minus 10 all over 16. This gives us two different answers. We have x equals 8 over 16, or 1/2, and x equals 12 minus 12 over 16, or 3 minus 3/4. As I said, this method is guaranteed to work every single time, but it is known to be the slowest. Will more videos come? That really depends on how the rest of the school year goes and what we do in projects-wise. But if this truly is the last time we meet, I hope you have a good day, and goodbye.